Welcome to the Cybersecurity module. In this module, we'll introduce the fundamental concepts of cybersecurity anyone working with smart lighting and other smart building technologies within the DoD should keep in mind. A couple of key points to keep in mind throughout this module. It is impossible to cover all things cybersecurity in the brief time we have here today. Additional learning will be required to gain all the necessary knowledge to effectively implement a smart lighting solution. The material is not meant to overwhelm anyone. Instead, it is meant to introduce concepts and key pieces of information to help you, the audience, ask the right questions of your local experts as you drive towards a smart lighting solution. These are the topics we will cover today. First, an overview about why someone should even be concerned about cybersecurity, to include real-world examples of compromise. Second, we'll discuss fundamentals of cybersecurity. Next, we'll go through relevant smart building technology concepts. In addition, we'll touch on the risk management framework, commonly referred to as RMF, and briefly introduce key terms and concepts. Building on RMF, we'll discuss what aggregate risk is and why this matters for smart lighting solutions. Finally, we'll leave you with a list of key documents and references to use throughout the selection and implementation process. On one end of the spectrum, people think the adversary isn't after or simply can't impact their systems. On the other end, people are so terrified of technology, they don't have the opportunity to benefit from the great strides we've made in smart buildings. In the middle of those two is a healthy level of concern about implementing smart building technology. An engineering firm in Germany had implemented a complete building automation system. The system controlled heating, ventilation, and air conditioning, light switches, motion detectors, window shutters, and more. During installation of the building automation system, a device was left exposed to the open internet. You might ask, why does that matter? How can someone find a random system connected to the internet? There are systems around the world with the sole purpose of scanning the internet for vulnerable and connected systems. Websites like Shodan will provide subscribers with a list of connected devices. These things can be filtered based on the type of traffic seen from the device, making it very obvious to the adversary what is connected. For example, traffic from a web server might have a lot of port 80, 443, and 52 traffic. But traffic from a smart device may just be some random high port that looks intriguing to an adversary. It's unknown exactly how this device was discovered on the open internet, but at the end of the day, it was. The adversary gained access, wiped the configurations from each device, then locked them with a hijacked bus coupling unit key. This key is, ironically, used to secure the devices from unauthorized access. Instead, the administrators of the systems are now locked out. The engineering firm lost contact with hundreds of devices, everything from light switches to motion detectors to window shutters. They literally couldn't even turn the lights off. The firm reached out to the vendors of the devices for assistance in gaining access to them. Since the vendors didn't have that BCU key, there was nothing they could do. The firm reached out to security researchers who eventually recovered a key from a device to restore the connectivity. For several weeks up to that, the engineering firm had to manually flip central power breakers to turn the lights on and off. Again, the point here is not to scare anyone away from using smart building technologies. Instead, it is showing the importance of using proper configurations. Had that device been properly configured and not exposed to the open internet, this would not have happened. Why should anyone care about cybersecurity? Yes, the DoD said so. None of us liked it when our parents said that to us as kids, and probably don't appreciate it when said to us today. However, we should all care about ensuring the integrity of the mission. Like any information technology system, the DoD requires approval to use smart and/or connected systems, including smart lighting systems. When someone wants to add software or hardware to the network, it must be approved. The same applies to smart lighting solutions. When smart lighting is added to a facility, what, if any, change is there to the risk of the mission, information, and people in that facility? The answer may be little to none. However, the risk assessment can't just be a guess. There's a process called the Risk Management Framework, or RMF, we'll talk about in more detail at the end of this module. It's doubtful the German engineering firm discussed earlier would have thought installing smart lighting or any other component of their building automation system would result in the havoc they experienced over the course of weeks. It is possible they did proper risk assessment and determined the risk was low, simply missing configuration on a single device. The resulting weeks' efforts should have been identified as a potential outcome, a risk of their building automation system being compromised. This is why the DoD requires authorizing officials to assess the risk of systems. The authorizing officials are rarely the ones doing the work of documenting the system. However, they are responsible for accepting the risk. The authorizing official for your system will provide an authority to operate, also known as an ATO, or an authority to connect, also known as an ATC, prior to system implementation. An ATO will be issued for a system considered standalone, one that does not connect to any other systems or networks. If the system connects to an existing network, it will be issued an ATC. ATOs for lighting systems are often deprioritized and do not get approved as standalone packages. To improve the likelihood of success, it is recommended to attach the lighting system documentation to a larger building automation accreditation package. The process to get there takes time, and although it may seem daunting for someone who hasn't worked with RMF in the past, it is achievable. It is critical to make sure systems are as secure as necessary to minimize risk to the mission. Before diving into risk, a little perspective. Think about the world's most secure computer. Go ahead, take a moment and picture it. Many people will picture some system on a classified network, maybe one that's not even on a network at all. Some people will think of securing tools or monitoring software. Those are all good things. But the most secure system is not only disconnected from a network, it's powered off, unplugged from the wall, placed in a waterproof safe, and sunk to the deepest part of the ocean, all while still being guarded by armed guards. That is also the most useless computer out there. That's why we have discussions about risk. The risk formula is often stated as vulnerability plus threat equals risk. There are variations on this equation for sure, but this is the simplest version. A vulnerability is a weakness in a system, procedure, or policy. Using a house as an example, not having a lock on the front door of a house would be a vulnerability. It's unknown if that is a risk just yet, but it is indeed a vulnerability. A threat is anything that can exploit vulnerabilities. The exploitation can be intentional, think an adversary, or even unintentional, think an authorized user. Back to the house example. The threat could be known criminal activity in the home's neighborhood. Now, risk is the combination of vulnerability and threat. With the house example, there's no lock on the front door. That's a vulnerability. And there is known criminal activity. That's a threat with a high likelihood of occurrence in the area. That combination indicates a higher level of risk. However, just because there's a vulnerability, that does not automatically indicate high risk. Let's change the house scenario. There's still no lock on the front door, so there's still a vulnerability. However, there is a moat, drawbridge, armed guards, and an electrified fence around the property. Also, the property is in an area with no history of criminal break-ins. Again, the front door still doesn't have a lock, so the vulnerability has not changed. However, the threat changed significantly based on the likelihood of occurrence and the addition of mitigating security controls. With the basics of cybersecurity covered, let's spend some time on smart lighting solutions. First and foremost, it is critical to understand this is not the same as business IT. Smart lighting systems do not operate like a desktop computer with office automation software on it and, consequently, will not be treated the same way. One similarity, however, is the importance of thinking about cybersecurity as early in the process as possible. Waiting until the end of a lighting solution selection process to give consideration to the cybersecurity implications will only serve to delay or outright halt the selection altogether. The Army Corps of Engineers has been tasked to design the Unified Facilities Criteria, or UFC, which serves as the building code for the DoD. These contain mandatory requirements for all DoD facilities, and some include code for cybersecurity-related concerns. UFC 4 TAC 010 TAC 06 is the cybersecurity code. They also created the Unified Facilities Guide Specifications, or UFGS, which implement the UFC. These serve as a baseline, but can be modified from project to project to account for specific requirements and implementation details. UFGS 250511 is the cybersecurity relevant document. Although both UFC and UFGS are used to set the baseline, specific implementation requirements are pushed to the commands. This is why it's critically important to have local points of contact who understand the process from start to finish. As lighting solutions continue to mature, wireless solutions have proven themselves easier to install and maintain. However, there is a general resistance to Wi-Fi in the DoD. This should not be interpreted as a recommendation to stay away from wireless solutions. Instead, it's simply an acknowledgement of the perceived attitude towards them and the need to follow the RMF to ensure appropriate risks to the mission are identified and mitigated. The risk management framework has been mentioned a few times throughout this module. It is a framework, emphasis on the word framework, vice a checklist, applicable to all systems within the DoD. It's used to identify, assess, and mitigate risks. Before diving into the graphic here, it's important to note the RMF is a lengthy, involved process. It was said before, executing RMF can seem overwhelming if a novice attempted to do so on their own. There are entire training courses for people with careers focused on implementing the RMF. Again, this shouldn't scare anyone away from implementing a new system. Instead, it should encourage people to understand the process at a high level and seek assistance with implementing it properly. In this module, due to time constraints, each step will only be briefly touched on. In a future module, the steps will be covered more in depth. Step 1. Categorize the system. Here, a system is categorized based on its confidentiality, integrity, and availability requirements. Remember, smart building technology is considered platform IT. Step 2. Select the security controls. Appropriate security controls, often in the form of overlays, will be selected based on the category and type of system. Step 3. Implement security controls. The security controls from Step 2 must be applied if they haven't been so already. This can be in the form of policy, procedure, or even technology itself. This step can be a sticking point. If the system does not meet the required controls or cannot be modified to meet them, the risk of not meeting those controls must be mitigated in some other way. Step 4. Assess the security controls. A third party will assess the controls implemented in Step 3 to ensure they achieve the intended effect. As a platform IT system, assessments will be different than traditional business IT environments. Often, assessors will attempt to scan systems for vulnerabilities, which is great for business systems. However, platform IT systems aren't always compatible with traditional vulnerability scanners. It's worth highlighting that to your assessor if they don't already know. Step 5. Authorize the system. Here, a plan of actions and milestones, or POAM, will be built to lay out how any deficiencies identified in Step 4 will be taken care of. This is the step where the AO will make the risk determination and either issue an ATO or an ATC. Step 6. Monitor the security controls. The work doesn't stop once the system is implemented. The implemented security controls must be continuously monitored, and the status must be reported to the approving official. Yes, there is a lot to this, but it is doable and has been done by many organizations across the DoD. Remember, this is just an overview of the RMF. There is an hour-long module being developed as a follow-on to this project. The assessor mentioned on the last slide is known as the Security Control Assessment Validator. They are an independent entity tasked with validating the documented security controls are indeed met. Using the UFC and UFGS will help when planning for cybersecurity early in the smart lighting selection process. The documents will also help provide mitigating steps for controls you just can't meet. RMF was built with business IT systems in mind, so some things are not going to map cleanly. Having mitigating steps in place will help the process along. Again, this isn't just another RMF application. When reaching out to the local communication squadron or staff contact, emphasize the effort will be for platform IT. Although it may be less vulnerable by having a smaller attack surface, it will get more scrutiny. Individuals steeped in RMF may not even have experience implementing the framework with platform IT and instead be focused on business IT systems. Do not be scared. This can be done, and with a basic understanding of the process, you will be ahead of your peers while navigating through it. There are a number of documents required in support of RMF. As mentioned on the previous slide, make sure you are checking for any pre-existing packets to streamline the process for you. As you dig through the documentation, you'll see some documentation with pieces and parts that do not apply. Remember, the majority of systems going through RMF are business or enterprise IT systems, not platform IT systems. A few highlights. You'll need a network diagram that shows the solution and everything connected to it. If you ever hear system boundary, that is referencing the imaginary line around your lighting solution, where everything inside the line is called in scope of the project. Generally, this will include all connected components of your solution. You'll need a complete list of all hardware and software required to implement the lighting solution. The ports protocols matrix, sometimes referred to as the PPM, lists information about how systems communicate between components. An example of a protocol would be Bluetooth Mesh or Zigbee. A system inventory including all of the systems, not just the components. The product white paper describing the system implementation and use. You'll also have to show how current security configurations will be applied or are already applied through something like a vendor security guide. And finally, the system security plan, which contains a lot of these artifacts, but also includes a section where the required security controls are documented as implemented or not, and how so. Imagine there is already a building automation system of some sort in place. For example, an HVAC system. That system has already gone through the RMF process and has been operating smoothly for some time. The addition of a smart lighting solution may have no impact, right? Maybe. If the smart lighting system stays completely separate from the HVAC system, then there's no impact. However, if there's a desire to control both the HVAC and lighting solutions through some sort of centralized control system, now accreditation boundaries have been crossed. Remember, systems must be as secure as needed to be accredited. Once accredited, the systems have an imaginary line drawn around them called the assessment boundary. Everything about the system, let's say the HVAC in this case, is within that boundary. Software, hardware, policies and procedures relevant to the HVAC system are all within that assessment boundary. The same would be said for a smart lighting solution. All of the software, hardware, policies and procedures for that solution would fall within the lighting solution's assessment boundary. If those two systems are connected in any way, the assessment boundary has changed and now encompasses both the HVAC and the lighting solutions. Any risk identified for them as individual systems must be relooked at to determine if there's any aggregate risk. The lighting solution may have been approved in part because it was standalone in nature. It didn't connect to anything other than the components of the system. The HVAC system, however, has connectivity to the open internet based on the technology being used to operate and monitor it. By connecting the two systems, the lighting solution now has a path to the open internet and must have new levels of risk that may be identified and mitigated. This is not a complete list of documents. Instead, just a place to start. The first three listed here will provide relevant overall DoD guidance, to include 8510 focused on RMF. The last two are the UFC and UFGS discussed earlier. This concludes the cybersecurity module.